Yeah, good morning, children. So, as you know already, so I'm going to revise two chapter, that is motion chapter and Newton's laws of motion and force and Newton's laws of motion. So, I told you to just revise the chapter, which is already present in your 8th standard syllabus. You already learned it. We'll just go through that and we'll solve some of the numericals and we will move on to the Newton's law of motion, laws of motion. So clarity is not good. So it is everyone's problem or only Ruchita but problem? Am I audible to you, everyone? Am I audible to everyone? Okay, thank you. Yeah. So I'll share some screenshot here. Just by the help of that, we will learn the chapter. Is it visible? Children, is it visible? Okay. So already you know the motion. You have studied the motion chapter in 8th standard. So motion means what? So change of position. Motion means what? Change of position of an object. If an object change its position with respect to some reference point, reference point. So an object is at A and it is moving to the at B. So there is a change of position of an object. When there is a change of position of an object in unit time with an reference, then it is called as motion. So see here. So this is your home. You think that this is the reference point. So home is your reference point. So from here you are moving from a place. This is a place, A place. You are moving to place B. So there is a change of position. See here. The initial position was this. There is a change of position here. So when there is a change of position in unit time, then it is called as motion. So whenever there is a change in position of an object in unit time, then it is called as motion. See, the body is said to be in motion. Body is said to be in motion when its position changes continuously with reference to time, with reference to a reference point. I am here now. This is my reference point. I am moving from here to 5 meter that side, left side, right side. That means I am changing my position with respect to time. So I have taken certain time. See, I have taken certain time to move from here to that place. So that is a change of position. And my reference point is this. You can see here in the screenshot. So change of position of an object in unit time is called as motion. Just note it down. See, a body is said to be in motion when it changes position continuously with respect to a stationary object taken as a reference point. See, I have taken here. The home is my reference point. So I am near the home and I am changing the position here. So from A place I am moving to the B place. You think that B place is a school. So from moving a distance, 100 meter, you think that. You think 100 meter, you have a school from your home. So this is, means home is a reference point. From there I am moving. So how much time I am taking? And this becomes a reference point. This becomes a reference point for me. Is it clear? Write it down. Already you know it, just I will recapitulate it. See, I have given here an example here. A car, you can see the screen here. A car is in a place, A place. This is a place A. Come here. Sit here. Sit here. Take that. With a reference point, always say this home is a reference point. Home is a reference point. This car is at place A at 8 p.m. You think that 8 p.m. it is there. From A to B it is moving and it is taking from A to B, to move from A to B it is taking half an hour. Here. So then again this car is moving. Same car is moving from B to C. Again it is reaching at 9 o'clock, means again it is taking 30 minutes from B to C. B to C. I hope you are getting my point. So here see, this is home is a reference point and there is a continuous change of position. Continuous change of position with respect to a stationary object. So this way, the home is a stationary object. Home is a stationary object and the object is moving continuously. So home is a reference point then. Understood? So this is the example. Here. Then, so one more thing next, that is distance traveled. Distance traveled. What is distance traveled then? So it is the actual path or actual length of the path covered by moving object. A moving object is here. See, this is a moving object. So a car is moving from A to B. So it is moving from A to B. It is covering some distance. It is the actual length of the path. Actual length of the path covered by an object or any person or object, any car, or like a man is traveling. You think that Abhiram is traveling from here to here. Abhiram school is house is nearby school. So he is walking from this place to this place, home to school. He is taking some time for this, and the actual length of the path covered by a moving object is called as what? Distance traveled. Actual path it is. So it is written here. Say there is the actual length of the path. It is like actual length of the path covered by a moving object, irrespective of direction. In any direction, you may go to any direction. The body has to be traveled. That's all. Write it down. Write it down. It is the actual length of the path covered by an object, irrespective of direction in which the body travels. Say why he is telling. So here see, I have written here like irrespective of direction in which the body is traveling. So we don't know that. We don't want the which direction we are traveling. We are traveling to east, west. We don't know. So distance traveled actually it is a scalar quantity. Distance traveled is a scalar quantity because we are not telling the direction over here. We are not telling any direction. Over here. That's why it's a scalar quantity. Scalar quantity will have only magnitude. Write down. Scalar quantity is having only magnitude. We are telling about the length traveled by an object. So I am going from say from Narebail, I am going to Sirsi. So it is the actual distance covered by an object. It is the actual length covered by an object. So we don't know the direction. We do not tell the direction. The person has reached there. That's all. Distance traveled. Distance traveled. So SI unit. What is the SI unit of the distance traveled? You know it already. Meter. It is meter. SI unit of distance traveled is meter. So ಒಂದು example ಕೊಟ್ಟಿದ್ದಾರೆ. A person is traveling. ಇಲ್ಲೊಂದು example ಕೊಟ್ಟಿದ್ದಾರೆ. So example is given. A person is traveling from A to B 5 kilometer. 5 kilometer. Then from B he is traveling to another direction. So he is traveling, just traveling 6 kilometer for the C. Then is going to from C to D he has traveled. So total distance covered. Total distance covered is how much?
19 kilometer.
Yeah. See here, 5 plus 6. 11. 11 plus 8. So total distance traveled I have written here. Distance traveled I have written here. See 19 kilometer. 19 kilometer. Total distance covered by the body is 19 kilometers. And I have mentioned over here, distance traveled is cannot be 0. Cannot be 0. See, distance traveled means we are changing the position. Distance traveled means we are changing the position. Whenever we change the position means we are traveling. We are actually traveled. That's why it cannot be 0. Cannot be 0. Why I am writing this? I will understand when I tell the displacement. Understood? SI unit is meters. Right on. And it is a scalar quantity because it is having only magnitude. It is a scalar quantity because it is having only magnitude. We do not tell the direction. Right on that. So I hope you understood the distance traveled. Distance traveled is scalar quantity because it is having only magnitude, not the direction. So next we'll go to the displacement. What do you mean by displacement? Displacement is a shortest distance between initial position to final position. Alright? Distance traveled from a place A to B. A to B. What is the shortest distance covered by in between A to B? So I'll give one. Say a boy is traveling from A is traveling. He goes to B. Point B. Understood? Then from B is traveling to C. From C to D. C to D. See here. So this is the distance traveled. A to B is moving and B to C and C to D he is moving. And so what is the shortest distance? See, shortest distance is this one. He can come, a boy can come like this also, like this also. See here, he can come like this also and like this also. Is it clear? Say A to B. A to B is there. A person has to travel from A to B. He can go directly like this, or he can go like this also. Can go like this sir. So you think that this 10 kilometers, it takes 5 kilometers, and this takes 2 kilometers. See here, you can see here. I hope it is visible to you. Is it visible? Is it visible, children? No, sir. Yes, sir. So AB is a place A, place B. Understood? A person can travel for A to B like this also. Person can travel like this also. So this path is taking 10 kilometers, this path is taking 5 kilometers, and this path is taking 2 kilometers. See here, a person can go from A to B like this by this route also, by this route also, by this route also. This is the shortest distance now. Shortest distance between initial position. This is initial position. Initial position. This is final position. Final position. Is it clear? So this is the shortest distance between two points is called as initial point, and final point is final position is called as displacement. Displacement. So what is the SI unit of displacement? So SI unit of displacement. So SI unit of displacement again it is a meter. It is a meter only. Understood? It is a meter. Understood? And it is a vector quantity. Vector quantity because it is having magnitude as well as direction. As well as direction. Direction ಇರುತ್ತೆ magnitude ಇರುತ್ತೆ. ಅರ್ಥ ಆಯ್ತಾ? So I told you, distance traveled cannot be zero. Distance traveled cannot be zero ಅಂತ ಹೇಳಿದೆ ಅಲ್ವಾ distance, but displacement can be zero. Displacement can be zero. Displacement can be zero. So displacement can be zero. See here. From a person is traveling to B. Understood? Because around 10 kilometers he is going from A to B. He reached here. Now he was traveling like this. In this direction he was traveling. See here. So in each direction is traveling. From west to east is traveling. So displacement. So we'll see now. Again he is traveling from B to A. B to A. B to A. 10 kilometers only. In this direction he is traveling now. See. So first he traveled in this direction, and second he is traveling from B to A. So what is the shortest distance between these 2 points now? So total distance traveled, how much? See, 10 kilometers he went to from A to B, then from B to A again he came back. Total distance covered. So total distance covered. Distance traveled. Distance traveled is 20 kilometers. 10 plus 10, 20 kilometers. 20 kilometers. 20 kilometers he has traveled. But what is the displacement? See, he has gone to A to B, again come back from B to A. That means he has come back to the same position. See, from where he has started, from A he has started, and he has come back to the B only, A only. Means So see, the shortest distance between initial position and final position is 0. Here it is 0 because again he is coming to the same place. That's why we tell distance traveled. Say distance traveled can be distance traveled cannot be 0, but displacement can be 0. Can be 0. Can be 0. See here. So I have given one more example here. From A to B, 2 kilometers is there. Again, a person is traveling from A to B. Again, from B to again is coming to the point A. Is taking 2 kilometers. 2 kilometers. So what is the distance traveled? Distance traveled is 4 kilometers. Total distance traveled, but displacement is 0. So displacement can be 0 because he is going to that place and coming back again to same place. So there is no initial position. So the distance between the initial position and final position is 0. That's why displacement is 0. Is it clear? So one numerical is numerical I solved over here. That we'll see now. How to calculate the displacement A, position A here. The object is traveling like this. So B to B, taken 5 kilometers, 5 kilometers, 5 kilometers. Understood? From B to C has come 3 kilometers, taken 3 kilometers. So we have to now calculate the displacement between these two places. Understood? So we have to calculate AC. So for this we have to use Pythagoras theorem. By applying the Pythagoras theorem, we can solve the we can know the shortest distance between two points A to B. So see here, A to B where he went and he came. What is shortest distance? That is calculated by, so AB square is equal to BC square plus AC square. So solve this. So AB is how much? So BC is how much? 3 square plus AC square. Solve this and tell me the answer. So I have already solved here. See here, 5 square that is 25 and 3 square becomes 9. 3 3s are 9 plus AC square, keep it like that only. Then so bring that 9 from right side to left side. So when you bring left side, sign changes. So plus becomes minus over here. 25 minus 9, how much? 16. So 16 is equal to AC square. Then I hope you understood this. AC square is equal to BC square plus AC square. So 5 square, 3 square plus AC square. So this becomes 25. Here 9 plus AC square. So 25 minus 9 AC square. Then 16, it becomes 65 AC square. So squaring it like this. So square root of 16. So therefore AC is equal to square root of 16 is 4. So 4 kilometers. 4 kilometers is a 4 kilometers is a shortest distance displacement. So remember this, very important, because this problems will appear in see common entrance test. ನಿಮಗೆ ಫ್ಯೂಚರಲ್ಲಿ ನೋಡಿ ಸಿ ಇ ಟಿ ಬರೀತೀರಾ, ಡಿಫ್ರೆಂಟ್ ಗೌರ್ಮೆಂಟ್ ಜಾಬ್ಸ್ ಆಗಿರ್ಬೋದು ಆರ್ ಡಿಫ್ರೆಂಟ್ ಪ್ರೈವೇಟ್ ಜಾಬ್ಸ್ ಆಗಿರ್ಬೋದು, ಏನೋ ಒಂದು ಎಕ್ಸಾಮ್. ಸೊ ದಿಸ್ ಯೂಶುವಲಿ ದಿಸ್ ಟೈಪ್ ಆಫ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ವಿಲ್ ಅಪಿಯರ್, calculating the distance, speed and all. So remember this. So this one, I hope Pythagoras theorem you have learnt in 9th. Have you learnt Pythagoras theorem in 9th? Nobody is replying. Yes, sir. Okay, okay. Yeah, in 8th only you have learned. Very good. That means you are knowing this. So this is about the displacement. See now, anyone tell me what is the difference between the displacement and distance traveled? Who will tell? Aditya Agade,
Yes, sir.
can you tell me the difference between displacement and distance traveled?
Yes, sir.
Tell me.
Sir, distance traveled is the actual length
So
covered
length covered by a.
moving body.
Okay, then.
Displacement is a shortest distance between initial and final position.
Okay, then what is the other difference?
Sir, displacement can be zero.
Can be
Zero.
Okay,
Distance traveled cannot be zero.
cannot be zero. Very good. Then one more difference. One more difference. One more difference. Who will tell one more difference? Yeah, Pranati Naik is replying. So scalar quantity. Distance traveled is scalar quantity and displacement is vector quantity. So because it is having the magnitude as well as displacement, sorry, magnitude as well as direction. That's why this is a vector quantity. Vector quantity. Okay. Yeah. So one more example I'll give for the displacement. Say in a circle, this is a circular track. Circular track. In a circular track, a person is moving from A. From A is moving, is going to B. Understood? 100 meters you think that. Understood? What is the distance traveled? Distance traveled is how much? 100 to A to B. Distance traveled. Distance traveled is what? A to B, that is 100 kilometer. 100 meter. 100 meter. Understood? Again from here, he is moving from B and coming to C. Again 100 meters. So again from so this is distance traveled A to B. A to B. Then again he is traveling from B to A. Again 100 meters. Both. So total distance. How much becomes total? How much becomes 200 meters? 200 meters. 200 meters here. But what is the displacement over here? What is the displacement? Say person has traveled from A, went to B, again from B to A he has came. That's why the displacement is 0. Displacement is 0. Displacement is 0. Understood? Understood? So here, say from A to B he went, then B to A. Take 100 meters. 100 meters you think that. So is traveling in a circular path and he is coming back to the same position. Yeah, Abhiram. Abhiram, what happened?
Yes, sir.
What is magnitude? Shreya, magnitude means quantity, quantifying something. Say, magnitude means, say I am traveling from Narabal to Sirsi. So I am going from Narabal to Sirsi. I am covering a distance. That distance that becomes a quantity. We are quantifying something. We are quantifying the length we have traveled. That quantifying, that's only magnitude. Magnitude means what? Quantity it is. It tells about quantity. Is it clear? Okay. So, means here I am telling line now. A bus is traveling 10 kilometers towards east. So here magnitude is also there, direction is also there. See, if direction and magnitude both are there, it is called as vector quantity. If I tell a bus is traveling 10 kilometers, I am not telling the direction over here. I am telling only quantity. Length, I am telling the distance travel, length. So that is nothing but only magnitude. Only magnitude means scalar quantity. Is it clear? So then we will move to the next concept, that is motion. Motion. Two types of motion are there: uniform motion and non-uniform motion. Uniform motion and non-uniform motion. So I hope is it visible? I hope it is visible to you. Yes, Sushrita is telling some problem. See, Sushrita, maybe your network problem here, network problem in your area. That's why you are having a disturbance in video and disturbance in the clarity of the voice. So from our end, there is no problem at all because the broadband is very good over here. There is no issue of network over here. That's why. Is it clear? there is a uniform motion and non-uniform motion. What is the difference between uniform motion and non-uniform motion? See, uniform motion means what? if a body travels in equal distance in equal intervals of time, if a body travels in equal distance in equal intervals of time. See, I have given an example here. Understood? The object is traveling from, say, A to B. Think that it is A, B, C, D, E. See here, A to B, 2 kilometers he has moved. See, you think that it has taken for 2 kilometers 1 second it has taken. Think that. So rocket speed it is. So rocket speed. So it has for 2 kilometers it has taken only 1 second. For next 2 kilometers again it is taken 1 second. For next 2 kilometers again it is taking 1 second. For next 2 kilometers again it is taking 1 second. See here, if you see, so a body is traveling in equal distance in equal intervals of time. If a body travels in equal distance in equal intervals of time, then it is said to be as uniform motion. Uniform motion. Understood? If a body travels equal distance in equal intervals of time, then it is said to be as uniform motion. Uniform motion. So I am going around 100 kilometers. I am traveling. For every 1 hour, I am traveling 20 kilometers. Understood? For every 1 hour, I am traveling 20 kilometers. So 20 kilometers I am traveling. So this is A place, B place, C place, D place, like that you think that. See here. So for every 20 kilometers I am taking 1 hour. 1 hour, 1 hour, 1 hour, 1 hour. So very simple. That's true. Total distance traveled how much? So 20, 1, 2, 3, 4, 5. So 100 kilometers I have traveled. I have taken for 100 kilometers I have taken how many hours? 1, 2, 3, 4, 5 hours I have taken. So see here. So this is a uniform motion. Uniform motion. So non-uniform motion means what? If a body travels unequal distance in equal intervals of time. I have given one example over here. See, there is one example in this screenshot, screen share. You can see here 2 kilometers. For traveling 2 kilometers, a person has taken 1 second. Next, for 3 kilometers, the distance taken is for next journey. Next journey has taken 1 second to cover 3 kilometers. Then 4 kilometers in next 1 second. See here, for 1 second he has taken 4 kilometers. 4 kilometers has traveled. To travel 5 kilometers, he has taken again 1 second. So there is a body is traveling in unequal distance in equal intervals of time. Equal intervals of time. That is called as non-uniform motion. So this is a graph. This is a graph which represent the uniform and non-uniform motion. Non-uniform motion. See here. So this in the graph, if you see the straight line, you can see the straight line over. This is uniform motion. There is no time change in time and change in distance. See here, straight line. The straight line in the graph indicates that there is no. So object is traveling in equal distance in equal amount of time. See here. But you can see one more graph, curved graph over here, curved line over here. So this represents the non-uniform motion because the object is traveling unequal distance in equal intervals of time. So this represents the non-uniform motion. Non-uniform motion. Write it down. I hope you have written it. So next we'll move to the speed. So already you have learnt about the speed, average speed, velocity, average velocity, difference between speed and velocity, all that. Understood? So we'll see that. So speed means what? So it is a distance traveled per unit time. It is a distance traveled by a body per unit time. So 1 unit time means for 1 hour, how much it is traveled? How much in what? How fast the object is traveling? So next 1 hour, how much speed it is? So per unit time means distance traveled by the body per unit time. Per unit time. So 1 unit time means 1 second ಗೆ ಇಷ್ಟು ದೂರ ಹೋಯಿತು. Next second ಗೆ ಇಷ್ಟು ದೂರ ಹೋಯಿತು. So like that. Understood? So write it down. It is a distance traveled by the body per unit time. So speed can be calculated by using this formula. Speed is equal to distance traveled by time taken. Already have learned this. Note it down. Speed is equal to distance traveled by unit time. So on this I will give one numerical. Solve it. So I'll give it. I'll send it through this thing. WhatsApp group. You solve it. Okay. So SI unit. So you know the formula of speed. Speed is equal to distance traveled by unit time. Understood? So SI unit is meter per second because distance. See, speed is equal to what? Distance traveled in unit time. So you know that distance traveled. What is the unit of distance traveled? Distance traveled is meter and time is second. That's why meter per second. Meter per second. So speed is equal to distance traveled divided by time taken. Time taken. See, what is the SI unit of what is the SI unit? So SI unit of distance traveled is meter and time is second. That's why it is meter per second. Meter per second. Meter per second. SI unit is. So as it is, see, speed is telling the distance traveled. What is speed? It is a distance traveled per unit time. Per unit time, this how much the distance is traveling. The object is traveling how much distance in per unit time. For 1 hour, how much it is traveling. For next hour, how much it is traveling. Understood? The body is moving from A to B. You think that. So 100 kilometer in 1 hour. 1 hour. Understood? So it is traveling 100 kilometer in 1 hour. 1 hour. Maybe in next hour it may travel 50 kilometer per hour. 50 kilometer per hour. Understood? That time you have to take average speed you have to take. I hope you are getting my point. This is the how to calculate the speed. Speed is equal to distance traveled by unit time. You have learned in previous classes, 8th, and also you have maybe learned in 6th and 7th about the speed in maths also. You have to calculate that. So here, so maybe from A to B, so 100 kilometers taken 1 hour. Maybe from again from B to C, it is traveling 100 kilometer, 50 kilometer. It may take 1 hour. So speed over here was more compared to A to B. You take 1 hour and here 100 kilometer, 50 kilometer you have taken 1 hour. So average speed you have to calculate for this. Understood? See, so one more, I'll share it. Average speed. So what is average speed? It is defined as total distance traveled divided by total time taken. So average speed can be calculated. Average speed can be calculated by this formula here. Understood? So it is defined as total distance traveled divided by total time taken to cover a distance. Understood? So write this formula also. The average speed is equal to total distance traveled, total time taken. Write on this. And you remember that speed is a scalar quantity because it is telling only the distance traveled. Here the direction is not involved. Direction is not involved here. Direction is not involved. That's why here it is a scalar quantity. Speed is a scalar quantity. Remember that. So I hope you have written it. So there is one example given here. An object travels 16 meters in 4 seconds. Say an object is traveling 16 meters in 4 seconds and then another 16 meters in 2 seconds here. In 2 seconds. So what is the average speed of the object? What is the average speed? So total distance how much? So object is traveling from total distance in the first half, first 4 seconds. Draw it so that you can. So A to B, it is moving like this. B it is moving. Understood? So it is moving how many? 16 meters. 16 meters. It has taken how many times? 4 seconds. 4 seconds. Again from B to C. How much? 16 meters. Same. Equal distance and equal time. So 2 seconds I think. Yeah, 2 seconds. Here. So for this we have to apply the formula average speed. So average speed is equal to distance traveled, total distance traveled divided by total time taken. So total distance how much? 16 plus 16. So it is 32. So total time taken how much? 6 seconds. So the answer is 5.33 meter per second. Like this we have to calculate. Understood? So do the second one. Same method. Do this second one. So can I tell that problem? It is already solved it is. That's why I'll give the problem. Try to solve it. Take down the problem. A train traveled. Yeah. A train A traveled A train A traveled a distance of 120 kilometers 120 kilometers in 3 hours. Whereas 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 another train B traveled a distance of 180 kilometers 180 kilometers in 4 hours. In 4 hours. Which train traveled faster? Which train traveled faster? Which train traveled faster? Do it. Do it on your own. Use the formula to calculate the speed of the train A. Use the formula speed is equal to distance traveled by time. For second also you do like that only. Second train, they have given, see, they have given the distance traveled of the second train also, 180 kilometers. Then in 4 hours, time also given. See, which train traveled faster? Tell me which train is traveling faster. Karun. Karun faster train is A. No, it's wrong, my dear. Calculate it here. You find out the speed first. Second train, Abhiram is right. Second train is, what is the speed of the second train, Abhiram? Yeah, Aditya, second train. Purnachandra, second train. Freya, second train. Train B. Train B is traveled faster. Okay. What is the speed of the second train and first train? So distance. So dt of train A. How much? Distance traveled is 120 kilometers. So time taken. Time taken is how much? 3 hours. 3 hours. So distance dt of train A. Very simple problem. So 180 kilometers. 180 kilometers. Then time taken is how much? 4 hours. 4 hours. 4 hours. So now speed of A is equal to distance traveled by divided by taken. So 120 divided by 3. So 40 kilometer per hour. So speed of B, how much? 180 is equal divided by 4. So 45 kilometer per hour. So that's why second train B is running faster. So train A 40 kilometer per hour and train B 45 kilometer per hour. So train B is traveling faster. Take down one more homework. Take it as homework. Take it as homework. A car travels 30 kilometer. A car travels 30 kilometer at a uniform speed of uniform speed of 40 kilometers per hour. Uniform speed of 40 kilometers per hour. 40 kilometers per hour. And next 30 kilometers and the next 30 kilometers at a uniform speed next 30 kilometer uniform speed of 20 kilometer per hour. Uniform speed of 20 kilometer per hour. So calculate the average speed. Calculate the average speed. Calculate the average speed. Solve this problem. So some more problem I'll send you by through WhatsApp in the group. I'll put some more problems. Solve that problems too. Is it clear? So in the WhatsApp group, your WhatsApp group, I'll send some more problems related to speed, distance traveled, and all. Just solve it that also. Okay. So next part of the lesson we'll see tomorrow. Do it in rough book only. Do it in rough book only. No issues. Chaya raising the hands. What happened, Chaya? Chaya?
Nothing, sir.
You are raising the hands over here. Abhiram, what is this 12.5 meter per second? Abhiram? 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 Huh? What happened?
Sir, nothing, sir.
ಕೇಳಲಿಲ್ಲ ನನಗೆ ಸರಿಯಾಗಿ.
Sir, just I sent the answer, sir.
Answer it is wrong, na? ಯಾವ್ದ್ರದ್ದು ಆನ್ಸರ್ ಇದು?
Sir, not for a train traveled a distance 120 kilometers in 3 hours.
ತಪ್ಪಲ್ವಾ ಇದು?
Sir, the second train fast unto sir 12.5 meter per second.
12 ಪಾಯಿಂಟ್ ಬರುವುದಿಲ್ಲ ಮಾರ್ರೆ. Second one is right. Second train is faster, right?
Yes, sir. Second train is faster.
Okay. Meter per second.
Train
Okay.
speed.
Meter per second. So, understood. You have calculated. Okay. Yeah, thank you. Okay. Any doubt till here? So this already have learned. That's a recapitulation for you. So I hope I have clarified the concept clearly. So in the next class we'll see the velocity and acceleration and problem related to those. Then we will go to the force and Newton's laws of motion. Understood? Okay. Thank you very much. Have a nice day.